Svein, you're one
Live
of the
streaming.
Hi there.
Hey Daniel, nice
How
to
are
see
you?
you. We're just having people joining us at the moment, so that's good. I've just turned on the live stream so that we can have a recording of this afterward as well. Hope that is good. Okay.
Yeah. Doing all right. How are you all doing?
I'm good on my side. I'm in the mountains of Norway, and then I think over there you can see how much snow it's on this up to the window.
Oh yeah.
So it's quite snowy and windy, but that's perfect for snow kiting. So
Oh, that's cool.
yeah. It's good. We can start with a couple of introductions, and I can begin. And just kind of will send the ball to the next one afterwards. I see there's a couple new faces here today, so I'll just start with myself first. My name is Snorre Edvin. I'm the co-founder of Din, also co-founder of Diwala. Have been in the SSI space for a long time. Have been running meetups on the side for a while, trying to educate the Nordic people about SSI. Daniel has been a guest in that meetup before. I'm happy that he wanted to come back again, because it's a much more technical bunch that's gathered here today, and it's also under a different subject. So I'll pass the ball onwards to Abele, who's been here a couple of times, and he's also working with me in a couple of research focused projects. So Abele, have you got some sound? If not, we can pass the ball to Marius. You just join. I'm gonna go over to NTNU now, and then we can move from there.
All right, can you guys hear me?
Yes.
Yeah, great. So my name is Marius. I'm also working with Snorre on some of the research projects from NTNU end of things. I'm interested in decentralized technologies in general, with the focus on decentralized finance and cryptocurrencies in particular. And we have a number of bachelor and master students working in that space. So yeah, it's good to be here. Thanks.
Good. We can take a couple of the new guys here. We'll start with Nick Mundada. Want to introduce yourself?
Hi, everyone. Yeah, sure. My name is Nick Mundara. I work as a product manager at Inrupt. We work with solid technology, so very interested in everything decentralized, including identities. And I saw got your invite through a colleague of mine, Arne.
Yeah.
He works with us, so I'm really interested in your meetup and looking forward to learn today a bit about DID and Microsoft. So
that's great. We can pass the ball to Ramesh.
Yeah, hi. I'm Ramesh, and I'm working with Diwala and Snorre. I'm working as a software engineer, and I'm interested in learning more into SSI and DIDs and how they work. I'm pretty new to into that area. So yeah, I'm pretty excited to learn this technology.
Great. Then we'll soon get to you, Daniel. I just want to hear from Svein. You can introduce yourself as well.
Yeah, hi everybody. I'm Svein Ølnes, work at Research Institute in Sogndal. I've been following this space, Bitcoin, blockchain, cryptocurrencies, for several years now, and yeah, trying to. I'm interested in everything that's moving. That's too much because it's very hard to follow everything. But I'm interested in learning more about Microsoft's efforts in this space. Thanks.
And you've also been part of application related to identity specifically, and how that kind of can affect the Norwegian society, right? Working to particularly also with the EU nodes and the efforts going on there.
Yeah, I'm working with you, Snorre, and Marius on a couple of proposals, and also other persons and institutions for trying to establish research projects in this space. So far, with limited success, I have to say, but we're still hoping.
We're still going at it. There's a way of entry there, I see. So last introduction, I'll take Jon Ørnes, and then we can go on to the outcome.
Yep, Jon here. Actually, Svein's cousin, last speaker. So we share a family name. I work at Signicat, product manager, working on different topics. And as you might know, Signicat is more the traditional identity stuff we're doing, coming out of being in the identity business for more than 10 years. But we're navigating, of course, all new IDs, new technologies, new ways of doing stuff. So yeah, we're definitely interested in catching up and following and being active in what goes on in distributed identity. I have to step out of the meeting pretty soon for a while, but I'll be back in later on.
Yeah, no problem. Great. So as we talked about the theme and agenda today, we invited Daniel to talk. He comes from Microsoft. He can introduce himself, but I'll just re-announce the agenda that we'll listen or hear a little bit about ION, why Microsoft built it. We'll hear a little bit about the presentation exchange standard that you guys, or I know you, Daniel, have been very active on. And I'll just want to remind everyone that this fora is working as an active conversation, but it's great that if you do have slides and can point to, while you talk, Daniel, we try to kind of have the possibility to ask questions along the way. And then we can also write questions in this chat if we want to take them towards the end. We'll try to keep this as a more low end for us to be able to have a conversation and discussion from what you introduced to us, Daniel. So I'll leave you to give it the table and.
Great, awesome. Can you still hear me?
Yep.
Okay, awesome. Yeah, so Daniel Buckner, I work at Microsoft on decentralized identity primarily from the angle of the standards and open source work, kind of in partnership with the product teams and stuff. So we do a lot of the ahead work that they then take and incorporate into some of their products and services. So we'll really be centering on two things today. One is ION, underpinned by this blockchain agnostic protocol called Sidetree, and then the other is presentation exchange that has to do with how issuers, verifiers, and holders interact and exchange proofs. So just to kick off, I guess we'll go over ION. I don't know how familiar anyone in the crowd is with ION.
Not ION itself. We have talked about general DID methods, and we talked about. We have mentioned in the agenda has had a Sidetree as a discussion subject, but you can do an introduction there. Okay.
Yeah. Let me go ahead and share this. Okay. So ION. What is ION? It's a layer 2 network that runs on top of Bitcoin. So when we say, Bitcoin, we mean, hopefully, is it like flashing?
Yeah, it's flashing.
It's flashing on my side as well.
Yeah, it's okay. Did that stop it? Okay, yeah, I don't know what I did. Just remaximized it. Okay, cool. So ION is this layer 2 network. It runs on Bitcoin. That's, I guess, controversial in some circles, but talk a little bit about what it is and why we did that. Primarily, ION, was born out of trying to solve scaling for the case where you really do want, robustly decentralized network. There's lots of ways to make DID methods, as you probably talked about in the past, given you said you talked in general about DID methods. So you can do all sorts of things. Like you could make very centralized DID methods like didweb, where some website just hosts your DID document. You just trust them. You can make didkey, very simple, right? But if you really wanted like an open index that has all these capabilities that you would want no central authorities, no validators, no stewards, no centralized Cabal or Libra looking thing, it's hard. It's hard to make it scale, and you're really going after balancing three things, which is the decentralization of the system, maintaining its security. And I think there's a lot that goes into the word security, but for me, like consensus system, all of the things that you'd want it to be, while scaling, which is something the monetary systems or the pure double spend systems have had a hard time doing to date. So I guess it helps to understand like what's the scale of decentralized identity. It's pretty significant, right? Like if you think about just humans, 7.5 billion people on the earth, and if each one of them just had one DID, right, one ID, that'd be a lot of IDs. So we don't think people just have one DID. We think they'll have many, and there might be IDs for cars and IoT devices and other things that aren't humans. So the scale is pretty massive, right? And so we need a system that can reach that scale. Technically, what is ION? Like I said, it's a public permissionless decentralized overlay network that runs on Bitcoin. Uses a deterministic protocol, and that protocol is Sidetree. Sidetree is a protocol that's been developed in Diff. It's used by a number of methods, Elements, Trust Block. There's a Cosmos one. There's a couple others. What it really is kind of a meta protocol. Like it's something that you can apply to blockchains or systems, and it'll have the same operational capabilities and functionality. You do need to pair that protocol with some sort of root of trust. For ION, it's Bitcoin, but Elements and the folks at Transmute are working on one that's root of trust is in Ethereum. And you could make really anything your root of trust. Sidetree allows anything to be the sort of the proctor or the determining body for order of transactions. And your security guarantees will follow with what you pick, which kind of leads to why we picked Bitcoin, right? So without saying the word blockchain, why do we even have these systems? Like what's it about? Blockchain's the easy buzzword, but like really what you're looking for with PKI in general is a global immutable append-only log, so that there's some series of events, right? Alice has created her ID, and you have to track it through history and make sure you're outputting Alice's correct state, right, at any given time. And so that kind of, unless you trust authorities and you just say, like the certificate system, here's the, certificate for google.com. Why? Not because you understood its lineage, but just because here, I said so. If you don't want that, you want a global immutable append-only log. No centralized providers or authorities. We'd rather not have that if we could avoid it. And we want it to remain censorship and tamper resistant to the full ability we can, right? So as much as possible. Now, what are some technical assumptions about, that we wanted to have about ION, about Sidetree? No secondary consensus. We were hoping for zero secondary consensus. We don't want to run another expensive consensus layer on top of an existing consensus layer, like say Bitcoin, Ethereum, or whatever. So that was an explicit goal. It allows for scaling beyond what other systems would, whether they be gossip systems or Byzantine systems or agreement systems. And then no conflicting states are allowed. So there's no ability to interpret data in any subjective sense. So all the nodes in ION do not have any sort of subjective consensus among themselves. They don't agree what Alice's state is, and then they all, sort of determine it themselves. It's all based on math. It's based on purely deterministic functions over data. And then one big key one that does allow for the scale, this is a really critical one, is IDs are not transferable between entities. So that's a big one. Like, so keep in mind that in ION, we assume that the ID, you creating the ID, you always own it. So there's no like Alice sells her ID to Bob, There's just no safe capability. It's totally doable. Like technically, it's like it's possible, but you need to really trust the person who's selling you something, because there's the capability that it's always theirs if they decided they wanted it to be.
Can I ask one question? It's there's a lot of second layer solutions on blockchain in general,
Sure.
but you guys wanted to build one that was highly specific for identity or DIDs. That's the kind of the main purpose here, right?
Yeah, absolutely. I mean, this layer really is. I guess the interesting thing is SideTree itself is essentially an authenticated CRDT. It's a conflict-free resolution system. So, like, technically, you could converge any data with the authorship of the changes being rooted in like the possession of keys. But yeah, it's essentially attuned for PKI, for decentralized public key infrastructure systems. And the specific thing that we eliminated, which is the transferability, and I'll kind of go over this in a little bit more detail, is the thing that makes it scale, right? Because when you do transference, like, for instance, there's all these projects like ENS and Unstoppable Domains and all of these systems that have transfer or registrar type capabilities. When you do that, you go back to like pure double spend. And if you do that, there's certain barriers to scale that just can't happen because settlement is required, right? There has to be a consensus over data, and it has to be a, kind of a subjective consensus that is settled. Whereas SideTree, there is no consensus because you can't do transfers. So it's sort of a big, concept to understand. But I'll talk a little bit about the system. Ion is, like I said, public and permissionless. So Microsoft doesn't run any like sort of master node. There's no signatories. You don't have any like validators like in Ripple. There's nothing like that. It really is just a system of essentially mirroring data between nodes and then processing it. Right, and processing it in accordance with a set of functions that are just purely deterministic. So if I was Alice and I went to like node 1, I could go to any node. I could fire one up just like I fire Bitcoin up on my machine, and I could do Bitcoin transactions. Essentially, the gating factor to Ion is only the capability to do a Bitcoin transaction. If you can do a Bitcoin transaction, you can write to Ion. That's it. That's about it. There's nothing else you need to do. If I was node 1 and I was Alice, I could either be running node 1 or I could go to someone who is doing it, who's out there running node 1. The capability is being able to write to Bitcoin. So the only reason I would go to someone else in this system is if I wanted to do it more cheaply, right? Like I didn't want to write to Bitcoin myself. I wanted to have someone else do that for me because it's expensive, right? It is an aggregation protocol. So let's say node 1 was Microsoft and Alice is creating her DID for the first time. She would create this DID operation, which is like the initial look of her DID document, maybe a couple keys in it and maybe an endpoint, something like that. And she would sign over it on her client. So the keys are always hers, right? Like they never left her machine. It's not like Microsoft owns her keys or whoever node 1 is has control over anything. They're basically receiving an operation that's signed by her keys so they can't tamper with it. The worst thing that a node could do that's aggregating for you, that's doing this role of essentially removing the economic burden from you, is not publish it. That's the worst thing they could do, right? Is they could say, oh yeah, I'm going to publish it, Alice, but then they don't, right? But you can validate that, right? You can actually just watch for your transaction, and if it doesn't appear, then it didn't appear, and you can go somewhere else, or you could do it yourself on Bitcoin, and so there's total openness there.
Yeah. And then that basically means that Ion is not dependent on a mass, like a critical mass of nodes. It can live on one because it bases itself on blockchain, or?
Yeah, that's the interesting thing about Ion, because so other systems, like you'll hear about like Carry and these other systems that are based on gossip and trusted circles and all this stuff. Their startup condition for the world is they have to have lots of nodes because you have to have like diffuse trust. You have to like pick a bunch of custodians, or there has to be people out there to interface with and to create this network. The cool thing about Ion is like, yeah, technically if there's one Ion node, really all it is data maintenance. Like store some data. Like if you can just have one node storing the data, you have the Ion network. It gets better, obviously more robust, just like any torrent essentially would on BitTorrent when you have lots of people that have the data. But you can have a network with a single node, which is, and it's totally trustless. So that's the cool part. Like you could have one node in the system and you're not even trusting that. So that's pretty cool. So what Alice does is she gives her operation to say, Microsoft running node 1. We put it into a batch. And these batches are basically just files that can have like lots of operations in one file, and they can have up to about 10,000 operations, right, in one file. And so that file, or series of files, I should say, is kind of compiled down to one anchoring IPFS CID. So Ion uses IPFS as its backing CAS, or content adjustable storage system. And so all of that batch is distilled down into one string that is essentially the address to the anchor file, and then leads to all the other files that comprise that batch. And so that anchor string is anchored into Bitcoin in an opreturn. And what all the other nodes, like node 2 is doing, is looking for the strings in opreturn transactions after the genesis block of Ion, and trying to find those that have these strings, essentially. And when they find one, they are IPFS CIDs, so they look it up, they look up the data, and they try to replicate it and mirror it. So it's a system of aggressive mirroring, essentially, of data mirroring. And node 2 will use that IPFS hash and go get it from whoever has it. Certainly the person probably who anchored it, whatever that node is, and however many people it was propagated to, after they created it. So the system just constantly syncs data like that. There's a transaction processor inside each node that just takes data and sort of compiles it. So Ion, like I said, is a CRDT. It's a series of delta changes over someone's state. So if Alice started in state 1 and then she did 3 changes, those changes would essentially be surgery on her initial state, right? It's like, I remove this key, I add this key. It's not like blowing it away each time. It's doing delta-based changes. And they converge in a conflict-free way. And that's when the data is found, it just merges into the state that it should be. So it takes, Alice's 4 deltas and says, great, I'm going to, turn them into one thing. And this kind of gives you a show of the basic, files. There's a couple more files in there that are linked to from the anchor file, but this is just a really, really high level sort of, look at it. It's like there's the anchoring transaction in the blockchain. It leads to this anchor file. There's this batch file at the end of the rainbow, all those being in IPFS. And then there's these sort of patches, right, that patch state. And this is the cool part, Bitcoin is really only used in tie breaking. So it's there for order. Like really all we use the blockchain for is the order that things happened in. Because in this protocol, Alice could create maybe she's going from state 2 to state 3 and she creates state 3A and 3B. She tries to fork herself, right? In the sense that she creates 2 divergent forks of state and then tries to anchor them. That's fine. That's totally fine. Alice can do that. But one of them is going to fall in a transaction earlier in Bitcoin. And so this protocol just has one very simple and deterministic rule, which is the first found wins. So the first file with a state change for Alice is the one that's picked. And essentially all nodes have that exact same deterministic function that they rely on. So this is a little bit about what a CRDT is. You've all used a CRDT in the past. You are, probably are going to today in your work today. Google Docs and HackMD and all these things are CRDTs. They have change. Essentially, you're changing a document, little additions and subtractions to the document, and those things are sewn together in a way that allows people to type on all ends of the world into the same document, and it's converged in a way that makes sense. It doesn't end up like gobbledygook. It ends up just as it's supposed to be. And that system is a conflict-free replicated data type system. And it's been around for a while. These are not new systems by any means. They use typically Lamport timestamps or vector clocks as their means of doing this. And there's a lot of trust involved in the typical CRDT setup because really what's happening here, you can see in this graphic, is where it says these integers like delete 1, insert 2, those things. What that really is are counters. They're literally just integers that say like, I'm Bob and you're Alice, and I just did my first change and my second change. And you're trusting the participants to increment their changes basically in order, like in the right order. And then you're also trusting a coordinator, in the case of Google Docs, like Google, to put the changes together correctly to show you the correct document. Now, the whole reason why the typical CRDT system is trusted, like Google Docs or Microsoft Word, is because you need some oracle for time, right? That's really why those things are centralized, because there's no way to say, I actually know in time when Alice changed the heading to my document, right? There's no concept of time in the world, really. That's untrusted, right? It's always just timestamps coming from some client or some server saying this is so. Now, that's actually what the blockchain gave us, which was, originally Satoshi's concept of it, which is time chain. And that's really what Bitcoin is. It's a time-based record of events. So that's all we use it for. We use it for its most primitive thing that it was actually envisioned for, which is below money. Money is a sort of outgrowth of your belief of what Bitcoin is, but what Bitcoin is principally and empirically is a time chain of historical events. So
it's a global clock.
What? Yeah. It's really just a big clock, relativistic clock. Yeah. So massive scale, we operate the network at 1,000 operations per second today. I mean, it could go higher. You should be weary of people who talk about amazing scale claims. The bottleneck for, say, Ion, it's unlimited in the sense that it's an embarrassingly parallel system because there is no secondary consensus. It's just data being, it's as fast as you can have bandwidth to sync data, essentially, and how fast a CPU can, parse JSON files. Right? Like we even delay the computation. So like when Alice's ID might have 4 changes, a node doesn't try to do all the signature checks and everything up front. It does those just in time. So unless they ever resolve Alice's ID, all they do is bucket data. They say, oh, here's another operation for Alice. Let me put it in the Alice bucket. So they're not really doing a lot of processing right up front. It's mostly just like file circulation, make sure the file matches the hashes that they showed they're the right files, and then breaks the files down and buckets them into a database. Other than that, it's not doing anything. So it's pretty parallelizable. Like our gating factor is really not the traditional blockchain stuff. It's more like basic technical things like bandwidth and how much storage it incurs. So at 1,000 operations per second, we can do about 50 billion DIDs in a minimum storage requirement of a little under 2 terabytes. So we could support network-wide 50 billion DIDs with about 1.8 terabytes of storage for the minimal trustless node, which is pretty good, right? I mean, if we had 50 billion IDs, then we'd be doing pretty good. I think it'd be a successful condition. So, but anything less than that, obviously just, we're down in the gigabyte range, which is good. And I think we can hack. Cost efficient, right? So people talk about how expensive Bitcoin is, but, even at $10 a transaction right now, if we packed it that 10,000 operations in each Bitcoin transaction, that's, per operation cost of 1/10 of a cent. So I think that's pretty good. Like we're not, Microsoft isn't crying tears over helping people for 1/10 of a cent. Did you have a question?
So I have one question, like how trustworthy, like I will say, since you batch, and I don't know how many transactions will come over a period of 24 hours or something like that. How much when does your ID become trustworthy if the system decides to wait 24 hours or 2 days to batch?
So the cool thing about it is the create operations can be used immediately. So we have this thing called the long form ID. There's like forms of ID, and this gets to the equivalent section of the DID spec that we had pushed to add, and we'll of course try to defend through CR, which is there's a form of the ID that can be used totally unanchored in a trustless way. And like typically your ID is going to look like, did : ion : and then some 32-byte hash, right? And the hash is the hash of your initial state. The long form of that ID is, instead of a hash after the colon, is a base 64 value of the actual initial state. So when I say initial state, I mean like the initial look of your DID document, your keys, public keys and stuff. So the long form of ID, if you pass that to an Ion node, it'll resolve it because it literally you're giving it the data. Right, it basically goes and says, well, if I can't find this on the network, right, then this is a long form ID, and I'll just hand you back the transformed, data that is your DID doc. So you can actually use your Ion IDs trustlessly the second after the millisecond after you create them on your machine, and you don't even have to care or wait any amount of time. In terms of trustless, the ability to trustlessly use a DID after there's been an update, whenever the network propagates. So if you used an anchor that does it every 10 minutes, you'd be fine in 10 minutes. You could do perspective, like resolution before it gets anchored. If you can find it in the mempool, we're thinking about adding stuff like that, like watching Bitcoin's mempool. And if there's transactions that aren't yet in a block, but we can see that they have the right fee and stuff, like a node could resolve those IDs, but then say, okay, well, it's pending, right? Something like that. So it's still resolvable, but it's not quite finalized yet. So it's just about, what your risk tolerance is before it gets a confirmation. But given it's provable, so the system is not transferable, there's no like ability to say, oh, if I, accept that Alice wants to transition her DID from one state to another, and it's just in the mempool, she could sell it to Bob and, I'd be screwed. Like that isn't possible because again, there's no transferability. So there's like the whole nature of pending kind of takes on a different characteristic when you don't have that vector. Okay, let's see here. So building the network, I'll go past this. Obviously, we're at a stage where we think that there's, some mid-sized companies, some large companies that are probably going to jump in and run nodes first. Then quickly, you'll see like the sort of individuals running it, as we release it. I think we're going to be in stage 2 here soon. That's going to happen is we're going to release Ion V1 in about 2 weeks. So it'll be production ready. It's running on production Microsoft. We're relying on it. Anyone can obviously run the nodes. It's an open source project with diff, so we encourage people to do so. It's pretty easy to operate. I'm running it on an Intel NUC. There's a buddy that we have in another division of Microsoft who's just like interested in the project. He's running it on a Raspberry Pi 3, so like it doesn't take a lot of processing power. This is not an intense system. It's mostly just bandwidth heavy, I guess, a little bit, but not much. So yeah. So how to get involved, participate in diff and all the good stuff. And there's both the repos there, and you can go check out the diff website. Yeah. So that's Ion. Is there any questions about that or?
Not to me. It's I've heard about it before, so I would love to hear if anyone has any curiosities on of the rest of the guys here.
Yeah, I just had a question that if you're only really using this sort of order from the underlying blockchain, in theory, you could use trusted timestamping and then batch the document kind of operations in a document, timestamp it, and then store it in IPFS and have it working exactly the same way without the blockchain layer, right?
So I will say that is basically what Ion does, right? So we're batching IDs. It's able to batch it. I'll go back to that display of what it does, which is here. So that's exactly what Ion does, right? So nodes aggregate operations into a file. They create an IPFS CID, and then they anchor it to Bitcoin for the time. It's not about timestamping though. That's one really important thing to understand. Like unlike open timestamps, which timestamps proofs of existence at a certain point in time, right? A timestamp is like this existed here. What Ion's interested in is what was the sequence of when something existed relative to something else, which is actually a kind of a different thing than saying like, oh, this picture was in the New York Times on this date. I'm not so concerned about what if an event happens on a specific date. I'm concerned with did an event happen before or after a different event in a series of history, right? And that's so you need some system, but you could think about it like timestamps if you want to. You need some system to anchor into that you can have the replayability of time. And so when you say you don't need a blockchain, I would say, well, if I wanted to create a quote unquote timestamp or series stamp, where would I do so, right? Where would I do so that is decentralized, that is deterministic, that can be replayed like in absolute immutable certainty? And so if someone can come to us and say, well, Dan, I've got just the system. It's just as decentralized as Bitcoin. Anyone can use it. It's permissionless. There's no authorities in the system, and it provides you this timestamp. I'd say, great. That's awesome. We could run Ion on that. But to date, we have not seen a stronger system than Bitcoin do that function, I guess is the assertion.
Yeah. And it's also important to kind of think about that Bitcoin is the one that's been living the longest, so it's been battle tested for the longest. So that's probably what part of the reasoning for saying that Bitcoin is the strongest chain out there right now.
Yeah. I mean, there's a lot of things go into it. Hash power, right? Reversibility of the chain it's basically incredibly difficult. I mean, you look at any other system and like the nice hash tables, like how hard it would be to reverse some systems, like BSV and others. It's kind of a joke, right? Like Bitcoin Cash, like, you know, if you had like $1 million, you could reverse like these blockchains. They're just, you know, and attack them. Well, 51% attacks. So yeah, absolutely. And then, you know, the battle hardened nature of it, and the fact that we don't need any smart contract stuff or anything like that. Like it's not even about that, right? It's just about series of time. So we can use the most basic blockchain in the world because really they all share this commonality. So if we're going to use the only thing being sequence of events, why not use the one that has the strongest characteristics?
Yeah.
Mm-hmm.
No, I get it. But like my complaint is that you sort of have a decentralized system which relies on this central processor. Like, you know, the nodes have to observe the Bitcoin blockchain, and you have to, you know, download all the docs and all the batches, and you have to keep track of the entire system. So each node has to keep track of the entire system, even if you're not interested of 99% of it. Even if you just have, you know, 2 customers which are doing something, then you still need to be kind of observing global state of everything, right?
Well,
each node has to do that, and that's kind of a lot of overhead, right?
So I should talk a little bit about that. So in terms of the file structures, if you see here, this is the file structures of a sidetree based system, which ION has these. It was simplified in the presentation, but there's actually 5 types of files. There's the anchor file, which links to this core, and anchor string links to this core index file, right? And this core proof file. These are like the backbone PKI, minimal data set operations that you must retain, right, to trustlessly know that you're resolving correctly. Now, these files, the provisional index file, provisional proof file, and the chunk files are transient. So they're able to be pruned after a certain checkpointing period. You don't actually have to have them. You can get them on demand. The minimal node will only keep the core index file. So technically, you only need this one file, which represents about 4% of the total data, and that will let you. That's why I said we could do about 50 billion DIDs for under 2 terabytes. So I would only have to track about 4% of the network's data to trustlessly resolve any DID in the system. Because what the core index files do is give you essentially a trusted map of the whole, you know, substrate. Like you know that Alice had 6 DIDs, and if you were or 6 changes to her DID, and if you were interested in resolving Alice's DID, you would go get these 6 provisional files and these chunk files, right? It's essentially like the map of the world, right? Without going and exploring the world, I still have this map where I can know where to go and navigate, right? So what you said is exactly what we've enabled very, very specifically in Sidetree, is to operate this at a scale where you can have a light node that only has this one file type, and is still just as trustless as a node that decides, like maybe Microsoft's like a big company, to keep all of it. And really, it's about speed of resolution. Like, you know, it's a little bit faster if you have all the stuff locally that you've stored on disk. So yeah.
Okay. Yeah. Thanks. That explains the way out. Yeah.
Mm-hmm. Yeah. Yeah. Cool.
I think we got a lot of things covered, so I think we can move on to presentation exchange.
Okay, so presentation exchange is a specification that endeavors to standardize the way that you can request proofs from a holder as a verifier, and you're kind of like stating what you want them to prove to gate something. It could be gating issuance of another credential. It could be gating, entry to something. So there doesn't have to be a response. I'll give you an example where there's not like a credential issued, which would be like if you change the door systems for badging into like verifiable credential, presentations. The door doesn't give you back a credential. It just opens. So the door could say, for me to open, I'm going to require that you're an employee of this company, or you're some sort of contractor who has like, a temporary access for the day or something based on, a credential that you were given, right? So it's how does a verifying party state for some purpose of verification the requirements to a holder? I'll kind of go into it a little bit. Presentation exchange is an embeddable data format that can ride along any sort of wrapper. So wrapper meaning like OIDC, like SIOP, OpenID Connect, DIDComs, CHAPI, verifiable presentations, whatever you want this outside to be, right here, this is all that's required. You sort of embed this. It's sort of like the Borg in the way that like it doesn't care how you send it to someone. It just needs to be within that package. So we did this because we wanted to use eventually DIDComm and CHAPI and other things, whatever we have to given the medium, whether it's a browser or it's like server to server or whatever. These are different protocols. We don't want to have the means of people describing what needs to be exchanged different across all of those, because that would be a pain in the ass, right? You basically got to go write the same code 5 different ways for 5 different types of transports. So what this does is allows you to reuse exactly that same code and logic in each of them. So if I was a verifier, like if I was, some customs agent, or, I was a business that was trying to validate something from a customer, I would send them, let's say through OpenID Connect, I would send them the initiating request and send them this presentation definition. This defines what I'm requesting of the holder, right? The person that has credentials that, I need to gate access on. Now, these input descriptors are essentially things saying you need to fulfill these criteria, right? If you don't have anything else, you just have a series of input descriptors, they're all required to be fulfilled. I could ask for things like an ID could be anything, like banking input, for instance. And I say, I need your account information and, here's why, for instance, and it needs to be a credential of this schema. So like, it's gotta be of this. This is the type of thing that we need, right? So this is, if you were to look at like, what's the most minimal presentation definition you could send to a holder, it wouldn't have constraints or anything else. It would just have like this right here. Just say, I need some banking information, and by the way, it's got to be a credential of this schema, right? That's the most high level request you can make, and that's fine for a lot of exchanges, right? But you can go further if you'd like to. You can add this constraints object here, which allows you to do things like say, well, I want you to limit disclosure. Only tell me about these fields. Or maybe you don't care about limiting disclosure, but you want to add some field checks, some filters to say, not only do I want you to give me a credential that was, banking standards, customer JSON, but I want you to make sure the issuer path is a string that's one of these patterns, right? Or I want you to give me a citizenship input, and it's got to be a US passport, and you got to make sure the birth date path in the passport is a date string greater than 1999, whatever, right? So what it allows you to do is something that none of the other credential, request sort of constructs do, which is like interrogate to the lowest level, down to the value level of what's in a credential that you're asking for, so that really the holder can understand on their side, do I even have what it takes to engage in this? Because the worst thing is to spin loading spinner on a user for 30 seconds while there's a bunch of chatter back and forth, and then at the end you could have known all along that the value needed to be above the number 12, right? And they were never going to succeed. Like they were destined to fail, and you just couldn't ask them these questions. So that's kind of what it does. And then there's a grouping component. Now this is a little more advanced. You don't have to do this. This is optional, right? It's not like required, but you might have a thing where you're like, hey, like there's sets of these things, and I want to give some optionality. So I might say the banking information, the rule for this group of A is that you have to pick one. Right? Pick one of many. It's kind of like multiple choice, right? And then for employment information, I need you to give me all of B. And then for citizens information, go ahead and pick one of C, right? So it's a very simplistic grouping syntax where you just tag these inputs with groups. And then when you're fulfilling it as the wallet, you're looking to make sure that you have, not only do you have credentials that meet the type and the values, but you also are fulfilling the combinatorics that they've given you, that you have at least one of the C's and one of the A's, that sort of thing. Does that make sense?
Yeah. So so let's just put it into a scenario, and that's like you can have multiple citizenships credentials. You can that is valid as a citizenship credential, but you just need one that's trustworthy. And when you take that bank information, you also include that it has to be from a certain issuer, meaning it has to be from a certain bank, probably. But just pick one of them. I don't care about everything. I just need one that proves that you have something belonging to that bank, and potentially the other things you're trying to constrain.
Exactly. And then similarly to this, there's two objects that presentation exchange defines: the presentation definition, like we've talked about, and then the presentation submission, which is like once I've gotten the things that, you know, I've essentially checked my credentials across these definitions, I need to then go submit a credential. So that could look like, let me give an example of that. So inside of OpenID Connect, it would look like this. I submit this presentation submission. It's always the same object. It doesn't change no matter, again, what wrapper you're sending it in. And it basically says, hey, I chose banking input 2 out of the selected, you know, I needed to pick one. And I chose citizenship input 1. And then, by the way, here's the employment thing you asked for. And what it's doing is it's using a path-based syntax to point to somewhere inside of its own payload where that data is, right? So what this allows you to do is take this exact same format and you could put it into DIDCOM, right? For instance, like presentation would go right here in DIDCOM, the same exact object. CHAPI, you know, that same object would go right here. Verifiable presentation, again, the same object goes right here. The only thing that changes is the path to data, because maybe these objects are structured differently, like these VP is different than a OpenID Connect sort of object. So all you're doing is mapping the inputs, the things that you were asked for and the ones you chose, and by ID, because you're referencing them based on what the verifier told you they're calling a certain input. And you're saying, oh, it's of this format, you know, it's a JWT that I'm submitting. And by the way, it's here. Here's where it's located. It's under verifiable credentials 0. So I'd go down to verifiable credentials array and then, oh, here's 0. And that's just basic JSON path, right? So it allows you to never rewrite the small library, which the entire spec can be implemented in under 500 lines of code in Go, like very verbosely, you know, a documented Go, not like some, you know, just nonsense, and use that across any transport you want, which is cool. You can reuse that same 500 lines. You never have to do this again, and makes life a little bit easier.
Cool though. I've been scrolling through the presentation exchange. It's a long document. Are you afraid that there will be details lost in implementations happening across, or what's like your biggest concern when it comes to that?
We need to get better examples of the minimal stuff, which there's actually a ticket in right now. Like for instance, I'll give you a for instance here. Like this basic example still isn't so basic.
Wow.
It talks about constraints and everything. What I'd like to see is us like pare it down to like eliminating everything but this, right? That's the most basic presentation definition you could present, which is like, what's the name of the, you know, this is banking information is what I'm asking you for. And what type? Oh, it's got to be a credential like this, right? Like if people saw that, it's a lot less intimidating. All this other stuff is like sort of advanced, you know, stuff if you really, really want to make sure that the holder has everything that they would need to know that they're not going to fail. Other systems like the OpenID Connect SIOP stuff are doing sort of description stuff, but what they're doing to not look so complex is they're just not giving you the power to do this stuff, which is sort of a trade-off, right? Like they're just saying like, oh, like basically like just submit this type of credential and that's all they're ever going to do. And they'll just let you fail, right? They'll let holders just throw data at the wall. And of course it'll just hit the wall and fall down because it's like could never have succeeded to begin with. And I suppose that's the comfort that they have. But a system that, you know, is simple, it's simple, but a system that implements presentation exchange, when you ask a holder for something, they're going to be able to know, even without talking to you or using up your consumption or sockets or anything, like, do I have what's necessary to make this succeed? That's really it.
So how's the community converging on this? Because like we all know that this Indian sovereign has gotten a very good traction just because they built the Ares agent and it's easy to get started with, and that kind of goes in their VC exchange. And like how do you feel the community kind of converges on this?
So DIDCOM. So the cool thing about this is we're working to get it as a recognized, you know, sort of embed in OpenID Connect. So we're using it in that right now. The DIDCOM folks are already in Ares libraries already picked it up. So they're using it in DIDCOMs. It's like an official thing you can do over DIDCOMs. So that and OpenID connector down. The verifiable presentation one is just generic, so you can always just do that if you want. Chappy doesn't need, the libraries for Chappy are easy. Like you can put anything in the data field of Chappy. So this is just basically what it looks like. And we've registered it and everything. So I would say that if you're talking about Indy and all those folks, they already are using it. And then we as Microsoft and Workday and a couple others have already picked it up and have implemented it. So it's all of our exchanges are via this method.
Are there has anyone announced like an open source library on this then? Because I can't find
there already is one right now in the repo. It's like presentation exchange implementations. There's Workday has a fully functional spec complete like 500-line Go library. I wrote about a half implementation in about 20 lines of JavaScript Node, which I will work on and get to all the way up to snuff and cover the whole spec probably shortly. But it's very I can always just show it to you. Code X right here. This is like it working live, and I can show you how it seems like a big spec, but really honestly, it's not. Like this is that entire portion of the spec that does the constraints and field validation. Like basically what you saw here, all of this, even the selections and the combinatorics, let me go up to presentation descriptors. All this, the selections and combinatorics is done in this, in essentially roughly 20 lines of code. So it's not super, it's not crazy, right? Like it's a big spec, but it resolves down to like a couple loops of recursion.
I guess that's the definition of a good spec, though.
Yeah. So yeah, I'm obviously using JSON Path as a library, and I'm using the JSON schema library. But these are pretty well-known libraries, right? Like we're relying on standards like JSON Path, JSON schema, very well used in the industry. So yeah.
Oh, cool. Any questions from the audience? I want to hear if like Signica has any thoughts on this presentation exchange. As Signica is the leading identity provider in Norway, and they're part of the building the way that Norwegians are able to identify themselves together with BankID. So they kind of see that exchange of credentials a lot, I guess. So I just wonder if they have any thoughts, particularly on this new way of doing exchange of credentials, if they're here. I know that both Jon Erik are here, but they might have left. That's he's one of the. Do you have any thoughts on this, or is it very new to you? Maybe people forget to unmute. They're here though. But yeah, I really like the way of thoughts around this, and it's a very interesting way to go, and it kind of wraps around a crucial missing part that the DID VC space has been needed, because you guys haven't seen any difficulties in people wanting to adopt it, as you said earlier, but has there been any battles you had to take?
Yeah, it's not really. There's people in the OpenID Connect community who are like, well, we're going to define, how we do inputs, and then we looked at the spec, and it's like, okay, well, all they define is like you can say what curves you accept for crypto, and then basically you can say like what schemas you want, or what JSON-LD types you want. And that's it. Yeah. So they're like, we solved it. And I was like, well, okay. That's still not going to tell someone if they're going to pass or fail, or like if they're going to submit the right shape of object. And they're like, well, we know what they're going to submit. They're going to submit JWTs. And I was like, okay, cool. So I guess this, OpenID Connect only works if you want to use JWT credentials, but then there's all these LD credentials. So the cool thing about Presentation Exchange is it's format agnostic, it's curve agnostic, it's envelope agnostic. Like it literally, all of these other sort of fiefdoms try to create their own little dialects inside of their envelopes that are maybe only inclusive of a part of the ecosystem. And Presentation Exchange is inclusive of the entirety of the ecosystem and can handle any sort of evaluation, regardless of what credential type or format of data or shape of things.
Yeah.
But you mentioned that this can coexist with Sovereign, so like it neither it just competes with it, and it doesn't like it can.
Yeah, I mean, so what I would say about Presentation Exchange is there is no standard out there. Even the Sovereign stuff, the way they do exchanges of things is not to this depth. So I think the reason why they accepted it is because they didn't have anything off the shelf. Like the Indian Aries folks who have now integrated this as a full project that is like an official one in Hyperledger. The reason they accepted it is because they didn't have anything to do this, right? And it just drills down to a level that no other protocol enables you to do. So there's really not in a cocky sense, but there's no competitors in that sense because no one's trying to do that, right? Like no one's really going to that extent.
Yeah, and it's worth mentioning that it's not you and Microsoft alone. It's actually people from Everdeen also participating in writing this.
Yeah, the co-editor of the spec is from, he works in the indie community. We have, the folks from British Columbia doing that too. We've got Workday in there, who are editors in the spec and contribute a ton to it. So yeah, I mean, it's a pretty broad base. Mm-hmm. Yeah,
and you got Martin covered, and he's also on the Ethereum side now. So it's there's a broad acceptance on this in my mind.
Yeah, we have Martin and a lot of the consensus folks participated. Yeah.
On like I missed some of the start, and I need to do some reading up. But did you cover sort of who? Does this anchor to you reference the Bitcoin blockchain, or do you need to submit a transaction to anchor these transactions? And if so, who pays the fee, or who submits this to the Bitcoin network? And if you could loop back on.
So just to qualify. You're talking about Ion, right? Which is obviously distinct from, Presentation Exchange, totally agnostic. Obviously, it's just credentials.
It was a question after your last presentation. Yep.
Yeah. So who pays, right? Whoever wants to do the anchoring of operations, that's who pays. Like you could pay if you're comfortable with anchoring a single, Ion operation in Bitcoin. You would pay whatever that fee would be. Obviously, that's considerable sometimes. We are operating a node that we're going to open up to everyone for free and cover the cost of transactions. We're going to write to the ledger once an hour. It's going to be a proof of work based system, not a blockchain type, but like I'm talking about like a DDoS gate. So we're going to gate people, but you can submit operations for free, and we will do it at no cost, at least for a while. But again, like 10,000 operations, $10 divided by 10,000 operations is a tenth of a cent, right? So if we ever had to charge people, literally just not to make money, but just to charge them to offset costs, like it's not going to be very high because costs.
And if you start building SideTree on top of layer 2 of the actual blockchain, things will then even go lower in cost. But that's a different discussion.
Mm-hmm. Yeah.
So how will you prevent, like you said, I think you mentioned 2 terabyte for
50 billion.
Yeah. I mean, to prevent sort of like a DDoS thing, where people just submit unnecessary stuff, how would that work?
So there is a max number of operations per block that are allowed. So you could set it in SideTree for whatever your implementation is. Ion caps it at about 600,000 per block. So you literally can't do more than that. Like it is rate metered. Like we have the opposite problem. Like it can scale unlimitedly because it's an embarrassingly parallel, like just in time system. It's just that we actually have to stop it from scaling. So it's hard capped. Yeah, just like Bitcoin is a hard cap of like 1 megabyte per block. we have a hard cap of 600,000 operations per block. So you could beat people trying to spam you by paying more. So the system, that is the only attack to the system that we're aware of, but that's actually the same attack for any blockchain, which is, people could pay more for transactions than you, but like that's sort of like this inescapable sort of thing that all blockchains have. Like, right? It's kind of,
Yeah. Well, that's great. We're kind of a little bit over time here now, but if there's any burning questions, we can grab them, or we can now say thanks a lot for the presentation. And I think it's been very, very a lot of learning.